This conference will now be recorded.
Okay, so good morning and welcome back to the session. This is Big Data Masters program. In the previous session, we were discussing about Redshift, and from the Redshift side, what we have seen like architecture of Redshift, and then we have gone through with practical on Redshift, practicals on Redshift. And what we have seen during the practical, like how to create Redshift cluster. Okay, that is the stuff. Then how to create tables and load data. That is the stuff what we have seen. And then we have gone started the concept for Redshift spectrum. Redshift spectrum. So with respect to the Redshift spectrum, what it is, like it is acting as a bridge between Redshift cluster and Redshift cluster and S3. Okay, so Redshift spectrum. This is Redshift cluster. Okay, we are having Redshift spectrum and we are having S3. S3. So, in the normal case, what is happening? We are going to create the tables onto top of a particular data, which is placed inside the S3. So, what we are going to do in the normal flow, like we are going to move the data. We are first create the table inside Redshift and copy the data in those table from S3. So what exactly is happening over there? We are moving the data. This is the normal case, Redshift, and this is S3. Okay. So over here, we are moving the data from S3 to Redshift cluster. Redshift cluster over here as well, we need to choose like how many node we need to have. Let me show you. So what is happening exactly over here? So let me log in into the AWS console. Inside the AWS console, what we are going to do, we are going to create a Redshift cluster. And what I have mentioned in our previous session, so this is Redshift, Amazon Redshift, and we are going to create a cluster. So create cluster. Let me click on to this create cluster. And over here, there are what I have mentioned, there are two types of node. Dense compute. These are the dense compute. There are dense compute and dense storage type of resources. So once RA3, that is dense storage resources. Like managed storage up to 4 TB, up to 128 TB, based upon the requirement. We just need to choose, like either we are moving with dense storage or dense compute. We are going through with a certain sample data only in order to learning perspective. So we are going to choose the node which are having list configuration, say 160 GB with two vCPUs. That is fine for me. And there is no need to have two nodes. I just need to have one node. So what exactly I'm going to do over here, I'm creating a cluster that will be having its own storage and core and memory. Okay, it will be a cluster and it will depends upon my use case how many nodes I want to have. And over here I will be able to see the pricing. So if I'm selecting the node that is of type dc2 large, and it is having 160 GB of the storage, so it is going to cost me around $182.5 per month. So that is fine. Now if you want to load the sample data, that is fine. You just click over here. The data will be sample data will be loaded automatically. Then there are certain you can say password related things. So I'm just going to provide the password manually. and I'm going to type a password over here. Say booster analytics. So boost analytics 1. This is the password what I'm going to pass. So boost analytics 1, boost analytics 1, that is the password. And I have mentioned in the previous session like how to create a role and how what are the permissions that we need to give. So you just need to create a role. I am having a role what I have already created with big data factory Redshift. So I'm going to associate this particular role. So inside this particular role, what you want to provide, you just need to provide the permission for S3 full access and glue full access. That is required in order to communicate with those two services. Then create cluster. So the like the cluster creation has been started. It will take a certain like 2 to 3 minutes, and till then like we can discuss over here. So what exactly is happening? I'm having a particular Redshift cluster, and that particular Redshift cluster, what is it is going to do? It is going to load the data from S3, and that data will be moved inside the Redshift cluster, and then I'm going to perform the analysis. Then I'm going to perform the analysis, like moving the data from S3 to Redshift, and then perform the analysis. This is the normal flow. This is the normal flow what we have done in our previous session, and we were able to do the execution. We were like we have created certain tables, and in those particular tables we have copied the data from S3, and then we were able to get the outcome. That is perfectly fine. So it was working fine. And like what is the mode, let me show you how you will be able to do. So just go through with this particular example. uh, Say we are having one table. Let me mention over here, this is an example. Oh, I'm going to create a table. Okay, so this is a table, say this is a table. Okay, so let me, this is a table what I'm going to create inside the S3 inside the Redshift cluster. This is the event table, event ID integer, not null. Okay, desk key. Okay, then venue ID, category ID, date ID, event name, and all, start date and time. So this is the schema or the structure of the table, and based upon the data what I'm having in my event, you can say file. In this particular file I'm having this particular data. So this is the way, like in order to copy. So first I'm going to going to create the table inside S3. Then what I'm going to do, I'm going to copy the data from S3 to this particular event table what I have created. This is the event table what I'm going to create, and inside the event table I'm going to load the data. Okay, you just need to provide the role name and delimiter, like that is the tab delimiter. Okay, so you just need to provide the delimiter and time format and all. So these particular things if you are not going to provide, it is going to like create the table and there will not be any issue. Okay, so what I have done over here, this is an example. We will be see it through practical as well. So we are going to create a table, and we will be going to load the data from S3. So from and how you will be able to read this, copy the data, uh, copy the all event underscore pipe dot txt file from S3 to event table using this particular role. I will show you from where you need to capture this particular role, and that is having tab delimiter and time format is this one, which is given in this particular event table data. Just have a look of this particular the data of this particular table. So I'm having this particular data. So complete structure course. So Redshift, inside Redshift, I'm having all event.txt. Yeah. So all event pipe. So this is the format. Like say first one is based upon the data what we are having in this particular table. We have created the schema. Okay. First one is event ID. Second one is say venue ID. Okay. Third one is category ID. Okay, fourth one is date id, then event name. Okay, and then the start time. Okay, this one is the start time, and this start time is in this particular format: year, month, day, year, month, day, and hour, minute, second. Hour, minute, second. And region, like in which region this particular data or table is present. Like in this particular region, the data is available. This in this particular location, the data is available. So that is perfectly fine. This is the way in order to create a table. And what exactly we are doing over here, we are creating a Redshift table inside the a table inside the Redshift cluster, and we are moving the data from S3 location to that particular Redshift table. Okay, so that is fine. This is with respect to the Redshift cluster. But we are having another component, that is Redshift spectrum. And what exactly the Redshift spectrum is doing, it is acting as a bridge between Redshift cluster and S3. So previously we are copying or we are moving the data from S3 to Redshift cluster, but this Redshift spectrum is saying what? That there is no need to move data from S3 to Redshift cluster. You will be able to query the data which is placed inside the S3 directly. So Redshift spectrum is created on top of Redshift cluster, and it is providing us the benefit that we can query the data which is placed inside the S3. The movement of data will is not required. There is no need to move data from S3 to uh, Redshift cluster. We will be able to query. So for this, we need to create the external table, and that's what we are going to see in our today's session. Previously what was happening, like we have created the external tables, but we were not able to query the data because there was certain errors. We need to mention the folder path instead of the table name. I will show you what was the issue, why we were not able to read, we were not able to query. So the cluster is available, the cluster has been created, and let me click on query the editor. Okay, so what I'm going to do first, I'm going to connect the database and connect. Okay, it is connected. Now what I'm going to do, I'm going to create the table. So you can take this particular table. So I'm going to create an event table. Let me copy and paste this particular the script for creation of event table. Okay, and the table has been created. Okay, so this particular table has been created, and you will be able to see over here the uh, event table is available over here. Now what we need to do, we need to load the data in this particular event table. So in order to load the data, in order to copy the data from S3 to event table, we just need to mention the location of this all event underscore pipe. So I'm having this particular data in my S3 table. Okay, S3 bucket, and I'm going to copy that particular path inside this particular query, and I will be able to load them. So I have created the table inside the Amazon Redshift. Now I'm trying to move the data from S3 to Redshift table. So we are having this ticket folder. Inside the ticket folder, what I'm having, all events underscore pipe.txt. Let me copy the URL and I'm going to paste it over here. This is the path of this particular file. Okay, S3 boost analytics ticket and all events underscore pipe.txt. This is the file which is placed onto the S3. Now I'm going to load this particular data in this particular table. This is the internal table or managed table. Now this is the table. This is the file which is placed inside the S3. And now just have a look. I just need to place the role as well. So in order to get this particular IAM role, what you need to do, you just need to go onto the Redshift cluster. Okay. And where you will be able to see the properties, and inside the properties you will be having the key which is utilized. Just have a look how to copy. So Redshift cluster, Amazon Redshift, and inside the Amazon Redshift, this is the cluster what we have created. And inside this particular cluster, you just need to go into the properties, and in properties you will be able to see the IAM role. So big data factory Redshift, that is the role what we have created. You need to click on that particular role, and now you will be having the AR, and you just need to click in order to copy that particular role, and you need to paste it over here. Let me paste it over here. Rest each and everything is fine. A delimiter is tab delimiter. This is like pipe delimiter is utilized because the data is having, let me show you. So this particular data is having pipe as a delimiter. So we have used that particular pipe as a delimiter, and the type format is this one. Let me copy this particular command, and I'm going to paste it inside the cluster, inside the editor. Okay, and let me paste it over here, and let me run it. Okay, so first I have created the table. Now I have copied the record, or I have moved the record from S3 to this particular table. That is perfectly fine. Now I'm able to uh, I have loaded the records, I have loaded the data from file to this particular table, and now I will be able to run the query. Select star from say event uh, limit 10. So I just want to have 10 records from this particular table. Just have a look. It is going to fetch 10 records from that particular table. So we are able to load the data, and we are able to query the data. That is perfectly fine. Now what about the Redshift spectrum? This is the normal execution, and over here we have created the Redshift table, and we have moved the data from S3 to Redshift table and a Redshift cluster basically, and then we are able to query the data. That is perfectly fine. This is the first way of execution. Now what about the Redshift spectrum? So for Redshift spectrum, what I need to create the external table. For Redshift spectrum, what I have mentioned in our previous session, that we need to create a schema. So what exactly the schema will do, that is going to add another entity. So say we are having a database, and in database we are having a database name, say database, and inside the database what we are having the tables. That is the normal flow. Okay, So database, what is happening inside the Redshift? So database will be having the schema. Okay, okay, and schema further have tables. So first we need to create a particular schema, and then inside that particular schema, by utilizing that particular schema and database, we are going to create the tables. Just have a look. So what we are going to do, we are going to create the schema first. We are going to create the schema first. Okay. So this is the way, like in order to create the schema, create schema, and this is the command in order to create the schema. Okay, so create external schema, and the schema name you just need to mention from data catalog. Data catalog, you will be able to see the data catalog and database my spectrum DB that you are going to create. Okay, and IAM role, you just need to paste the IAM role. This is the IAM role over here, which is utilized in order to create the schema. Perfectly fine. And create external database if not exist, if it is existing, that is fine, otherwise it is going to create my spectrum db. So my spectrum db will have this particular schema where I'm going to create the tables, that is going to add another dimension. Okay, so just have a look over here. I'm going to create this particular table. Hmm. Schema, sorry, I'm going to create this particular schema. Creates external schema my spectrum, uh, my spectrum schema. Over here, like we are having these particular schema, these are the internal schema. These are given by uh, Redshift only, yeah. But at this moment I'm going to create the external schema. Let me run it. Okay, that is going to create the external schema, and you will be able to see that particular schema over here. Okay, so it has been executed. Now just have a look over here. My spectrum schema, it has been created. That is the name what we have given, my spectrum schema. So by utilizing this my now what we need to do, we just need to create a table by utilizing this my spectrum schema. And this is the way in order to create that particular table. So what I'm going to create, I'm going to create a sales table. Okay, sales table, that is, you can say my spectrum schema, and dot sales, that is the table what I'm going to create, and this is the structure of that particular schema. And the location for this particular table, the location for this particular table, which data it is going to refer, it is going to refer the data. uh, I need to mention that particular path, huh? So over here, previously, just focus over here. In the previous session, what we were doing, we were uh, like uh, pasting the absolute path over here. Let me go on to the S3 first, and then I will show you. So previously, what was happening? Say this is the sales data, and let me copy the URL. So what was happening, we were mentioning the path in this particular way. Okay, so uh, this particular sales table which is having this particular structure, that is a text file and it is tab delimited. Okay, uh, so fields are terminated by tab over there, and it is going to refer this particular data. But what we have used the absolute path, huh? So absolute path, what is the meaning of that over here? We have mentioned the file name. Okay, that this particular file is going to be loaded in this particular table what we are going to create. But because of that only, we were not able to query the data. It was throwing certain error. So what we need to do, we just need to remove this particular table, the file name. We just need to mention the folder path over here. We just need to mention the folder path. This is very important. You just need to mention the folder path. And once you are going to mention the folder path, then you will be able to create the table. Table properties num rows, that is not mandatory, you can remove this. This is not mandatory. Okay, let me try to copy this one only. I'm not going to uh, use this particular clause, and I'm going to create the table uh, with this particular command. Okay, so let me do the execution. So I'm going to create an external table that is utilizing this particular schema what I have created, and the table name will be sales table, and it is going to refer this particular path. I'm going to create a table onto top of this particular data. Now just try to focus what we have done in previous execution. Previously we have copied the data. Previously we have copied the data, where we are mentioning each and everything. Okay, okay, so okay, previously what we were doing, we were creating a table and then moving the data, okay, copying the data from S3 to that particular table. But at this moment, what exactly we are doing, we are creating a table, and inside the creation of table, we are referring the path like this file or this location, this particular table is going to refer. So what exactly we are doing over here, we are not moving the data from S3 to Redshift cluster. Just by utilizing this particular Redshift spectrum feature, we are going to query the data which is placed inside the S3. Okay, let me copy this one. Okay, it has been already copied. Okay, and let me click onto the run, and I will be having this particular command. A table already exists. Okay, let me create the sales one table. Okay, sales one. I'm going to create this particular table. So I will be having that particular table. Let me use my spectrum schema. Okay, inside this, like I'm having sales is already having, like in my previous execution I have created this particular table on sales. So sales table is already existing. Sales one I have created at this moment. Previous execution once, like previously when I have created the cluster, so I have created this particular table. So my spectrum schema dot sales, this is the table what I have created. Now let me try to run certain queries. Say select star from uh, table, and in order to query, what I just need to mention, say select star from my spectrum schema dot sales and limit 1, limit say 10. So in our previous execution, what once we were executing previously, so we were not getting the outcome of this particular command because of this particular issue what I'm mentioning over here. So previously we have mentioned the the complete path by mentioning the file name over here. Now we have mentioned the folder name, and now it will work perfectly. Just have a look. Okay, the execution is keep on going, and now we are able to get the outcome. So previously we were not getting the outcome. In the previous execution we were not getting the outcome, but we are able to get the outcome. And what was the issue? This was the issue. We were facing certain issues because of, like we have mentioned the file name over here. We just need to mention the folder which is containing the file, and you will be able to query that particular data. Now the important thing that I have mentioned in our previous sessions, that what you can do, what you can do, you can join the tables, or you can query the data. Okay, so what exactly we are having? So we are having some data is placed inside the S3. Okay, some data is placed inside the S3. Let me mention in a detailed way. So we are having two tables over here, event table. Okay, and we are having sales one table. Event table, that is a managed table, and sales one, that is nothing but external table. Okay, and what is the another difference what I can say? Event table, like the data is available in Redshift cluster. The data is available inside the sales one. The data is available in S3, because we are not moving the data from S3 to this particular table. We have just created the table onto top of Redshift data, and then we are able to query. Now, the main purpose, like, can I perform the joining between these two tables? Okay, event table, which is the managed table, and its raw data is available in Redshift cluster. Let me mention raw data. Raw data. Raw data. Okay, and external table, the raw data is available inside the S3. So can we perform the join? The question is, can we perform the join? The join. Okay. Okay, so on event and sales table. So event table is this one and sales table is this one. So what I can say, we can perform the join, and how it will be, how we will be able to perform. So select top 10 records we are going to select. My spectrum schema dot sales. Okay, my spectrum schema dot sales dot event id. So from sales one, so over here my spectrum schema, this is the schema. Sales one is the table name, and event id is something what we have created. So in this, what we are having, we are having event id. Okay, so the schema, the table name, and the event id, and sum of my spectrum price idea. So my spectrum sales, that is the table name, and price id, I just want to have the sum of price id. This is a simple query, I'm just explaining it from spectrum sales. So from this particular table, then event, over here it is going to perform the join with event, where my spectrum sales one dot event id equal to event dot event id. This event id is available in event table as well. Just have a look inside the event table, we are having event id. So event dot event id, it is going to refer this particular table, Redshift uh, cluster table. So event dot event id, and my spectrum schema sales dot price id, that I just want to have greater than 30. Group by sales dot event id, order by two, descending order. So this is the simple query, and you can like mold it in different ways based upon your requirement. what I just want to show, I just want to provide you a feel that we will be able to perform the join between the tables where like we are having raw data inside S3 or where we are having the raw data inside the Redshift cluster. We will be able to perform the joining. Just have a look and let me copy this particular command and paste it over here. Perfectly fine. Let me do the execution. And we are able to get the outcome, event ID sum. So, so what I can say, we are able to perform the join based upon the data which is placed inside the based upon the raw data. Either it is placed inside the S3 location. If data is placed on S3 S3, then also fine, we will be able to perform the join. If the data is placed uh, inside the Redshift cluster, then we will be able to perform the join. If the data is placed inside the Redshift cluster and S3 location, then also we will be able to create the table and perform the join. That is the main, you can say, take from this. Just have a look onto this particular stuff and ask if you are having any doubt. Shivam, Rohit, and Raj Babu. Any doubt with respect to Redshift spectrum? What I mentioned? Mhm. Anyone, any confusion, anything that you want to ask? Rohit, Raj Babu, Shivam, anything?
No, it's okay, sir.
Okay, perfectly fine. So, what what is the observation? Like we just need to mention the folder path instead of the file. So, if I'm going to say, let me create a table over here and let me mention the complete path. Just have a look. Let me mention the complete path. Copy the URL and uh, let me paste the complete URL over here. I'm going to create the sales to table. Say- Okay, I'm going to create sales to table and let me paste it over here. Okay, so sales to table will be created. Let me remove this particular line as well. That is not mandatory. Okay, so run. The table will be created. There will not be any issue in table creation. Just have a look. We are able to see the table, my spectrum schema, and we are having sales to table. But once we are going to query the data on this particular table, we will be getting the error what we were getting in our previous execution. Just have a look. Select star from my spectrum schema dot sales to and limit say 10. Okay, just have a look. So we will be getting the error. So this is the same error what we were getting. Like past manifest is not valid JSON object. So that was the error which we were getting in our previous execution. So what is the take? You just need to mention the folder path instead of the complete path with file name. So it will work. It will work if you are mentioning the file name over here. It is it will not work. You will be getting the error when you are going to query the data. So that is the take, right? Let me uh, drop this particular cluster, delete this particular cluster. So Redshift cluster action and I'm going to delete it. I don't want to create a snapshot. Let me delete this. Perfectly fine. So we have gone through with Redshift, and we have seen like how the Redshift is behaving, how to create the tables inside the Redshift. Then with the help of SQL like commands, we will be able to query, we will be able to perform the analysis on to top of the data which is placed inside the Redshift. Okay, so that is the way how to work with Redshift. Then we have seen Redshift Spectrum as well, where there is no need to move data from Redshift from S3 to Redshift. We just create the external tables, which and those tables are going to refer the data from S3, and we will be able to perform the analysis onto top of that particular data. Once we are like curing, once we are working with data that is placed on as that is placed inside the Redshift, so we will be able to query terabyte of data. And once we are referring S3, then we will be able to query exabyte of data. That is the difference, like w- once we are working with Redshift and Redshift Spectrum. Okay, so Redshift is over, and like we have gone through with say EMR, Glue, Athena, Redshift, S3. Okay, so these are the different services what we have seen from a data engineer perspective, and if you go through with these particular services, so that will be fine. Now, there are other services as well inside AWS cloud, but from the data engineer perspective, these services are enough, and you just need to do the practice. Now, with respect to our learning journey, we are going to start a new topic, that is Kafka and Apache Kafka or Kafka. Okay, so Kafka was developed by LinkedIn. It is developed by LinkedIn in 2011, and this is basically a message broker. Okay, like it is developed by LinkedIn in 2011. So what was the need? Like there were like a lot of messages were there, and that particular load was keep on increasing, and they need to identify a solution, they need to find out a solution which will be able to tackle those particular increased amount of messages. Those will that particular solution uh, they were looking for, and they have designed this particular Apache Kafka. Nowadays, Kafka is very powerful tool, and it is utilized in order to build real-time application. Now, powerful tool to build real-time application. Okay, real-time applications. Now, as per official documentation, official documentation, uh, this is enterprise messaging system. This is enterprise messaging system, that is perfectly fine. Like it was developed by LinkedIn in 2011, and it is a powerful tool in order to build real-time application. And from the documentation perspective, it is enterprise message system, messaging system. Messaging system, but I'm bothered about what it can do for me. Like that is perfectly fine, it is able to do a lot of things, but how it is utilized, how I will be able to utilize this particular tool. So once we are looking onto the top level, the Kafka is looking like, say we are having producer, say one, producer two. These are certain fancy names. Huh? Producer two, producer three. Huh? So we are having multiple producers, and these producers are doing what? These are producing the messages. Okay, messages are produced by these particular producers, and then these particular messages are going to message broker. Message broker, let me mention over here, that is message broker. Okay, message broker. And then in the same fashion, what we are having, we are having consumers. Consumer one, I can say, consumer two, and consumer three. Okay, as the name is indicating, producer like is one who is producing the message. Producer is one who is producing the message, and this message broker, what it is going to do, it is going to receive the message, receive and store the message. Store message. So this is something like a messaging system. So what we are talking about, messaging system. Messaging system, inside the messaging system, what is happening, we are having different producers which are producing the message. Then like the messages are like given to the message broker, and then there are consumers who are going to read these particular messages. So consumers are reading the message, reading message, or what I can say over here, producer writing message, writing message. Okay, so producer writes the message. Then what we are having, we are having a message broker which is going to receive the message and store the message, and then we are having another entity which is going to read the message, that is known as consumer, and we can have multiple consumers. Uh, like that is perfectly fine for a small system. For the smaller organization, this particular system will work. There will not be any challenge. We are talking about like how this particular Kafka came into the picture. So so for the small organization, that is perfectly fine. Like message broker is able to read the message from the producer side, and it is going to provide these messages to to the consumers, and they will be able to consume those particular messages. That is fine. But if the organization keep on growing, then this particular system will become a mess, and it will be tough to manage. And it will be tough to manage. In order to solve that particular issue, once the organization data or the messages are keep on growing, then how to handle this particular situation, then like what we can say, Kafka is a solution for us. It might be possible like this particular consumer need to read the data from producer one, but the consumer two is also planning to read the data from producer one. Okay, so there are different issues what can happen, like once we are having multiple producers and multiple consumers. So at that moment, like we need to have a solution which is going to minimize the problems, and Kafka is a solution for that. So what exactly, like Kafka, if we are looking onto the top, uh, the Kafka will look like this. Just have a look over here. So inside the Kafka, what we are having a Kafka cluster. We are having a Kafka cluster. Then we are having producer over here. We are having consumers over here. A consumer, that is the same with respect to the messaging system. Kafka itself is a messaging system, but that is more advanced to the traditional messaging system. It is good with respect to the traditional messaging system. So producer, that is one who is producing the message, and consumer is one who is consuming the messages. Then we are having stream processor. So stream processors, Kafka is also providing a streaming API which is able to analyze and process the streaming data, which like we what we are getting live streams of messages from the producer. So we can Kafka is providing a feature or API so that you will be able to process that particular real-time messages and then share the outcome. If you want to like connect different streaming processor API, like you can connect the Spark streaming API over here in order to process the Kafka streams, then you can connect that particular Spark streaming over here and you will be able to process. So what I can say over here, Kafka is like providing the streaming processor as well, and it is not limited to Kafka itself. You can connect the external stream processor as well over here, and then you will be able to process those streams data, live streams of data. Then what we are having connector. Connector, that is an interface between database and Kafka cluster. So connectors are providing the mechanism in order to move the data from databases to Kafka and Kafka to databases. So we are having connectors over here. Now what I can say, so with the help of this particular structure, what I can say, this is not a traditional, let me mention over here. So, so Kafka is not as the traditional messaging system, but rather than it can simplify the complex pipeline that is made of lots of producer and consumers. Okay, so with the help of this particular diagram, what we are able to say, the Kafka is utilized in order to simplify the complex data pipeline, which is containing a lot of producers and consumers. So that is the outcome with respect to the Kafka. Then over here, another take from this particular diagram, you can use uh, use it as streaming processing platform streams. So Kafka Kafka over here, and if you are going to process it with Spark streaming, so Kafka, it provides you the streams and processing framework work. You can connect processing framework with it, like Spark streaming. Spark streaming. And then what we have seen, connector to connect uh, Spark. Oh, sorry, Spark is coming in my mind now. To connect Kafka with databases. So in this particular diagram, connector and stream processor, these are the new things what we are able to see over here, and I have mentioned it. So that is like something about the Kafka, like what exactly is there inside the, what is happening once inside the traditional system. Like traditional system, once the data or the messages have been increased, then it will become a mesh, and the traditional system or message broker is not able to handle. In order to handle the mesh like situation, we are having Kafka, and Kafka is acting as a streaming processing framework as well, where Kafka is going to provide the streams, and processing framework will be able to process those particular streams. So once we're talking about the different components inside the Kafka, Kafka. So once we are talking about components, so what we are having different components. Say first one, like producer is coming in my mind, then consumer, we are having broker, we are having cluster, okay, then topic and partition, then offset is there, and we are having consumer group. So these are the basic components once we are talking about the Kafka cluster. Just have a look over here. Hmm, okay. So this is a Kafka cluster basically, and it is containing producer, then producers which are producing the messages, and then inside the Kafka cluster what we are having, Kafka cluster, that is the combination of multiple nodes. It is not like say single machine is available over here. We can have multiple machines, multiple nodes connected to each other in order to serve these particular producers and consumers. So we are having multiple nodes over here. Inside the nodes, what we are having topic, and topics are containing the partitions. And we will be discussing those particular things. And then we are having consumers. So, so let me first explain these particular things, and then we will move further. So producer, that is the first thing. Producer, the first thing which is coming in our mind, like which is producing the message, producing the messages, okay, and like messages, or you can say message stream, or uh, like data, what I can say, which is producing message or data or message stream, whatever, message stream. So which is producing message. Message that is small to, what is a message basically over here? Small to medium, medium piece of data, medium size piece of data. Okay, that is nothing but a message. Now, in another words, what we can say? Message array of bytes. Array of bytes. Okay. So producers are nothing which is producing the message data or message stream, and message, what we can say, that is small to medium piece of data, medium sized piece of data. And in another word, what I can say, it is array of bytes. And this particular producer is going to produce, and then what we are having Kafka cluster, and then at the end what we are having consumers. Okay, so producers are going to produce the message which are given to the Kafka cluster, and uh, and then like we are having consumers. So producers are not directly sending the message to the consumer. Okay, so what we are having, producers uh, are going to like produce the message. These particular messages are captured by the Kafka cluster, and then finally it will be given to the consumer. What we can say over here, cluster, Kafka cluster, basically that is Kafka cluster, I can say Kafka cluster. Okay, Kafka cluster, what is that basically? That is, this is like combination of multiple machine, combination consisting, say, consisting multiple machines, machines acting together for a common purpose. Okay, that is nothing but a Kafka cluster. And what we are having the broker as well. Broker. Uh, so broker, what is the meaning of broker? Okay, so you can take an example, like if you want to purchase a property, so uh, you are a buyer. Okay, and then there are certain sellers as well. So the broker is doing what it is going to it is like that person is going to align certain meetings and all, and then finally the buyer and the seller will meet together, and they will be able to communicate, and then they will have a deal or not. That is depending upon them as well, at that moment. So broker over here is doing the same stuff. What I can say, this particular consumer and the producer, they are not communicating directly with each other. So what we are having over here, we are having broker, and that is a server basically. Broker, that is a server, and this, with the help of this particular server, it is going to act as a bridge, and then it is going to capture the message which is like given by producer, and then it is going to provide this particular message to the consumer. So you can say the producers and consumers are communicating with each other via broker. They are not communicating directly. The via medium is broker. So the broker is performing the same stuff what we used to see in our day to day life. So the broker is over here as well, like is going to perform the same stuff. Like over here, producers and consumers are not communicating directly with each other. The broker is going to perform that task for them, and they will be able to communicate with each other. Now the next component, what we are having inside the Kafka cluster, that is the topic. So topic, basically, what is happening, let me give you an example. Just just see this particular diagram. So what uh, we are having a producer, and we are having different consumers. We are having producers and consumers, and then, like, inside this, what we are having topic, broker, and broker is like containing the topics, and topics are further divided into partitions. Partitions are also like having are divided further, and another entity that is there, which is called as attribute. So partitions, once partitions are divided, that is called attribute. So we are talking about topic. So topic is going to capture the streams. Like, say we are getting the different streams from the data, from the producers, and those particular the topics are created based upon the flavor of data. Like each and every topic is having uh, different flavor, and based upon the flavor of the data, we are going to create the topic. In order to understand the topic mechanism in a detailed way, let me provide you an example. So what we are having consumer, and we are having broker. Okay, so consumer and broker, these are the two entities. So a consumer, what I have mentioned, this broker is acting as a bridge between producer and consumer. So consumer and broker, these are the two entities, and the consumer, say one consumer is there, and the consumer is asking, can you give me the data? Give me the data. The data. Okay, consumer is asking to the broker, like, can you give me the data? Then what the broker is responding, say, I am collecting data from say multiple producer. Which one you want? One you want. This is the same way, like if someone is going to purchase certain property, he's asking to the broker, like, I want to purchase something. What will be the broker say? Which property, which type of property you want to have? In the same way, it is responding like, I'm having multiple producers, which exactly you want? Then what the consumer will say, okay, give me the data. Okay, give me the data from, say, uh, ABC producer. ABC producer. A, or let me mention, say, ABC producer, like ABC producer. Or give me the data sent by ABC. Okay. So it is asking, say, I just want to have certain residential properties. Okay. So the broker is saying what? Okay. So the broker is saying, like, this consumer has said, like, I just want to have the data which is sent by ABC producer. Producer. So this particular broker is saying what? Oh, oh, producer ABC, producer ABC is pushing data, pushing data in three different records. Huh? You can take it in this way. The broker will say like I'm having the residential properties into three different sectors. Huh? Okay. So first like this particular property. Okay. Like it is saying say I just want to have residential properties. I just want to have certain properties. It is saying say which type of property you want. Like then it is saying say I just want to have the residential properties. Okay. Then it is saying say like I'm having the residential properties into different sectors. You can take it in this way. So it is saying say ABC producer send me the data which is sent by ABC producer. So it is saying say it is saying like the ABC producer is sending three different record. Okay. Then it is saying say okay, give me the data or give me the sales data. Okay. So it is saying what? Okay, sales data. Okay, you are looking for sales data, but two more producers are sending the sales data. Okay. Okay, so it is saying say you are looking for the broker, the consumer said that I'm looking for sales data. Then the broker said like I'm getting the sales data from two more producers. It is not like given by ABC only. I'm having two more producers which are sending the sales data. Okay, then you can take in this way. Okay, so with respect to our property example, like the consumer is coming, he want to see certain residential properties. Then it is then he's going to broker, and then broker is saying, say, I'm having the the residence properties in different sectors which you want. Then okay, he's saying, say, like show me the property, like which type of property you want. Then he's saying say I just want to have the residential properties. So he's saying say I'm having the residential properties into three different sectors. Okay, so he's saying say like give me show me the properties uh, from say sector 1. So he's saying that like I'm having the residential property in sector 1, but in which flavor you want, like you want say 100 yards or 200 yards or 300 yards plot, or do you want any do you want flat, or do you want say house, row house type of property, which exactly you want over there. Then the consumer is saying say, oh god, give me some identification mechanism, some identification okay, give me some identification mechanism. So this identification mechanism is nothing but the topic. So topic is going to have a stream of data. What I have mentioned, it is having a stream of data. So with respect to our property example, So what the broker is having, say sector 1 and say 100 yards float, 100 yard floats. Okay, sector 2, sector 3, and inside over here sector 1, what we can, he can have 200 yards. Okay. In this particular way, like the broker is going to to serve the consumer by providing the the flavor which exactly is desired by the consumer. Let me explain it once again. So the consumer is coming and he is asking to the broker, like, give me the data. Then the broker is asking, like, I'm collecting the data from the different producer, which exactly you want. Then the consumer is saying, give me the data from the ABC producer. So broker is saying, say, okay, that is fine. You are looking for the data which is published by ABC producer, but uh, he's pushing three records. Which exactly you want? Then he's saying, say, I just want to have the sales data. But this broker is saying, I'm getting the sales data from uh, different producer, two more producers. From which producer you want to have the sales data? So, oh good, like then he's saying, give me some identification mechanism. So over here, uh, the identification mechanism with respect to the data is nothing but topic. Topic is going to have, say, producer ABC, ABC, and say sales, say electronic sales, electronic sales data. Okay, sales data. Okay, and so the consumer needs to ask in this particular way, give me the electronic sales data from producer ABC. Okay, give me the electronic sales data from ABC producer. In this particular way, he is going to ask. Just have a look over here onto the diagram, then it is going to clarify, it is going to to clarify these particular things. So over here, what we are having, say, producers, and these producers are producing the data. So with respect to the uh, data with respect to the data, that particular data is captured in the topics. So we guys are going to create the topic based upon the flavor of data. We just need to like create the topic. Say we have created the electronic sales data, and that is from, we are getting from the ABC producer. So over here, this particular topic is going to have the data from, say, ABC producer, which is having electronic sales data. Okay, so this is the way, like this is the mechanism how the topic is working, and this is same like we used to say, what we used to say in our day-to-day life, like the broker is doing what, and with respect to like a stream of data that is captured inside the topic, and we will be able to, the the consumer will be able to have that particular data. Okay, are you able to understand, Rohit, Shivam, and Raj Babu, the concept of topic, what exactly topic is?
Yes, Ashok.
Yes, sir.
Okay, so Shivam, what about you?
Yes, sir, it's fine. Sir, do I need to do the practice?
This is the theoretical stuff. You just need to like
Sir,
clear
for
these
the
particular.
Redshift,
Redshift, yeah. For Redshift, definitely you need to do the practice. But from the
yes.
Kafka perspective, we have gone through with the
Yes, sir.
theoretical
So,
part only.
Kafka
Mhm.
perspective, it's fine, sir.
Okay, so topic is nothing but a stream of data, unique name. What I can say. A topic is nothing but unique name of a data stream. Data stream. Okay. Okay. Unique name of data stream, that is nothing but a topic. Okay. That is the definition of topic. Now, what we are having partition. Partition. The next topic, like, that is partition. So with the name itself, like, what we are able to get, like, it is going to create the partition. Now the topic what we are having, it might be possible this particular topic is not able to fit inside one machine. If the data which is captured in topic, which is captured in topic that may there, it might be possible uh, hmm. So the data which is captured in topic, it might be possible it might be possible that it is higher than the system capacity. Then we need to break the topic into smaller partition, and those partitions will be moved in different machines. That is the simple stuff. What we are having, say, if like we are having certain topics, and these particular topics are very huge in size, say we are getting the sales data, electronic sales data from a particular producer, and that particular data is very huge and it is not able to fit inside one machine. So at that moment, what we need to do, we just need to do the partitioning. Okay. And uh, then those particular partitions will be available, we will be able to load those partition into different machines. Okay. Now over here, we just need to decide how many partitions a topic will have. Okay. While creating a particular topic, we guys are going to create the topic. While creation of topic, we just need to decide how many partition we need to have. That is coming with the understanding of data. Okay, if you are having good understanding, then you will be able to define, you will be able to provide a good number or correct or accurate number with respect to the partitions. Like this particular topic will have 3 partition, 4 partition, 20 partitions. That will, these particular things will come with experience. So in order to create the partitions inside the topic, we just need to have the understanding of data. Okay, that is fine. So what I can say, producer produces the data, then Kafka cluster is bunch of nodes, then we are having broker which is acting as a bridge between consumer and producer. We are having topic which is going to like that is going to capture, or that is a name in order to capture a unique stream of data. The topic can be of higher size. It might be possible it is not able to fit in storage of one machine. Then we need to do the partitioning. We just need to do the partitioning inside the topic, and the partitioning must be decided while creation of the topic. Okay, so that is the stuff, and we just need to like utilize the data understanding skill in order to create the topic and apply partitioning onto that. Okay, that is fine. Moving further, what we are having offset. Offset. So offset, just have a look onto the diagram. These particular partitions, partitions are further divided into small records, and those are nothing but the offsets. We are having a topic. Inside topic we are having partitions, and partitions are having records. So what I can say, that is a sequence offset number. Offset is nothing but a sequence number. It is a sequence number given to masses as they arrive in partition. Once assigned, they will never change. Never change. So what is the locating mechanism? Topic, name, partition number, and then offset. Offset. So if you want to locate a particular message in topic, you just need to provide this particular locating mechanism. You need to provide the topic name, partition number, and offset, and that is nothing but a sequence number that is given to a particular message. So if you want to have the message say record number 3, you just need to provide the details like topic 1, partition 1, and record 3. In this particular way you will be able to locate. If you are mentioning say I just want to have the record 3 from this particular topic, then probably this record 3 will be available into partition 3 and partition 1. Which one you want? So you need to specify the accurate locating mechanism like topic 1 partition number and topic name, partition number, and offset. So this is nothing but a locating mechanism or lowest entity in order to locate a particular message. This is the sequence number which is given to each and every record once that particular record is coming inside the partition. Okay, so this is the way in order to locate a particular message in a particular topic. Okay, perfectly fine, is it? Offset, are you able to get offset?
Yes, sir. It's fine.
Okay.
Yes, it's fine.
Yes, sir.
Consumer group. Consumer group, that is the last thing or last top component. Consumer group. So just have a look over here onto the diagram. What we are having producer, then we are having Kafka cluster, and then we are having consumer 1, 2, consumer 3, consumer 4. Over here email group. So these particular consumers are consuming the email data Okay, email, and these are, you can say, responsible for processing, say, email data, and these particular consumers are responsible for processing the payment data. So why we need to have consumer group? It might be possible the incoming data that is very huge and single consumer is not able to process that particular data. So we can add multiple nodes in order to process that particular data, and those particular nodes will form a group, and that is known as a consumer group. Say you are getting the data from a particular network, and that particular data is very huge, and you are not able to handle that particular data. What you will do at that moment? You will add more nodes in order to process that particular data, or in order to, like, get the outcome or get the understanding from that particular data. So you are going to create certain groups, and those particular groups are known as consumer groups, huh? So what I can mention over here, many consumer form a group to share the load, to share the work oblique load. Okay, and what I can say, large task is divided among multiple persons, among multiple persons, multiple persons. So maximum number of consumers in a group is equal to, so max number of consumer in a group is can be equal to number of partitions in a topic. Okay. So what I mean to say over here, say, uh, huh. Okay. So over here, like, we are having topic one. This particular topic, just focus onto the cursor. Okay, this is the topic, and we are having multiple consumers over here. We are having a consumer group which is going to consume the data from this particular topic. Now, how many consumers I can have in this particular group? That is, like, we are having a particular thumb rule. Okay, because, like, what we just want to share the load, so that, like, this particular topic can be consumed by different, you can say, different consumers. So what I can do over here inside the consumer group, in order to share the load, I can add the consumers equal to the partition, if, like, two consumers are working on one partition, then I will not be having the information which data is moving to which consumer. Okay. So that is a thumb rule what we are going to utilize. What we are going to have, say, the number of consumers in a consumer group is equal to, can be equal to the number of partition. Each and every partition is, like, moved to one consumer, and that particular consumer is responsible for that particular partition in order to do the processing. So that is a thumb rule what I can say, like, maximum number of consumer in a group can be equal to the number of partition in the topic. and Kafka is not allowing the data uh, from one partition to be read from different consumers. Okay, it is not allowing, say we are having this particular partition, it is not allowing, say one partition is read by two consumers. There are certain, you can say, properties. We will be discussing those particular things in detail, but that is what like we need to understand. Inside the Kafka, we are having different components. What I can say, producer, which is producing the records or message. Consumer is going to consume. Consumer group, once like the load is high, then uh, multiple consumers uh, add together and form a group, and those are going to perform work onto the same that particular task. Then broker, which is acting as a bridge between producer and consumer. Kafka cluster, this is the combination of multiple machine in order to load and uh, store, read and like in order to load and process the messages basically. Then topic, that is like unique name which is given to a particular data stream. Topic is further divided into partition, and partition is having lowest entity, that is offset, and it is a sequence number which is given to a particular message once the message is coming inside the partition. Consumer group, we have already discussed, like we are having multiple nodes, consumer nodes, which are put together in order to to work on a common task. So I think that's it for this particular session, and we have gone through with Redshift practical, Redshift Spectrum practical, and like introduction into the Kafka, and rest of the stuff we will like cover in our next session. Let me stop recording and take your queries.